Hello everyone, I am Brandon Ordonez from ECE31 and today I'm gonna try to perform experiment number 4 for our digital electronics laboratory, which is titled Boolean Algebra. Brandon's log. The objectives of this experiment are to check the theorems of Boolean algebra in practical approach, to simplify the logic equations using theorems in Boolean algebra. These are the materials needed for our experiment: a 5-volt power supply, our breadboard, our different integrated circuits, and our LEDs. Lastly, our connecting wires. For the first part of the experiment, we will be tackling about double inversion. For this experiment, we will be using a 7404 integrated circuit. So let us try to build the first part of this experiment. So I have finished building circuit number 1 for this experiment. So let's try to fill the tables. Upon connecting the input to the ground, the LED does not light up. Upon connecting the input to the source, the LED will light up. The second part of this experiment uses an AND/OR combinational circuit for the absorption theorem. So let us try to build the circuit. So I have finished building the second circuit for this experiment. So let us try to fill the tables. This experiment uses a 7408 integrated circuit and a 7432 integrated circuit. Let us try to fill the tables for this part. Upon connecting both inputs to the ground, the LED does not light up. And upon connecting input B to the source, the LED does not light up. And upon connecting input A to the source, the LED lights up. Upon connecting both inputs to the source, the LED lights up. The third part of this experiment uses again a 7432 and a 7408 integrated circuit, but in different arrangement. So let's try to build the circuit. So I have finished building the third circuit for this experiment. So let us try to fill the tables. Upon connecting both inputs to the ground, the LED does not light up. Upon connecting input B to the source, the LED lights up. Upon connecting input A to the source, the LED does not light up. Upon connecting both inputs to the source, the LED will light up. The fourth part of this experiment is about the distributive law. So for this experiment, we will be using a 7432 integrated circuit and a 7408 integrated circuit. So let's try to build the circuit. So I have finished building the circuit for part 4 of this experiment. So let us try to fill the tables. Upon connecting all inputs to the ground, the LED does not light up. Upon connecting input C to the source, the LED lights up. Upon connecting input B to the source, the LED does not light up. Upon connecting inputs B and C to the source, the LED lights up. Upon connecting input A to the source with inputs B and C to the ground, the LED does not light up. Upon connecting inputs C and A to the source, the LED lights up. Upon connecting inputs A and B to the source, the LED lights up. And upon connecting all inputs to the source, the LED lights up. The fifth part of this experiment uses a 7432 and another 7408 integrated circuit. It is another demo for the distributive law as shown in the previous experiment. So let's try to build the circuit. So I have finished building the last circuit for this experiment. Now let us try to fill the tables. Upon connecting all inputs to the ground, The LED does not light up. Upon connecting input C to the source, upon connecting input C to the source, the LED lights up. Upon connecting input B to the source, the LED does not light up. Upon connecting inputs B and C to the source, the LED lights up. Upon connecting input A to the source, the LED does not light up. Upon connecting inputs A and C to the source, the LED lights up. Upon connecting inputs A and B to the source, the LED lights up. And upon connecting all inputs to the source, the LED lights up. So after observing the tables for the circuit, we come up with the conclusion. The first circuit of the experiment can be written as A prime prime, which when simplified would be y is equal to A. Therefore, the input of A would be the same to the output. If the input is 1, then the output would be 1. If the input is 0, then the output would be 0. The second circuit can be written as y is equal to BA plus A. And the simplified version of this would be A. Therefore, whatever is the input of A would be the result of the circuit. If A is equal to 1, then Y would be equal to 1. If A is equal to 0, then Y would be equal to 0. The third circuit can be written as Y is equal to B plus A quantity multiplied by B, which when simplified would be Y is equal to B. Therefore, whatever is the input for B would be the output for Y. If B is equal to 1, then Y would be equal to 1. If B is equal to 0, then the output Y would be 0. The fourth circuit can be written as C plus B multiplied by C plus A. When simplified, we can write it as C plus BA. Therefore, the product of the inputs A and B when added to C would be our output. If A is equal to 0 and B is equal to 1, the product of it would be 0. If C is 1, therefore 1 plus 0 is equal to 1. Therefore, the output would be 1. The fifth circuit can be written as B multiplied by A quantity plus C. Therefore, we can observe that it has the same equation with circuit number 4. For this experiment, I recommend that you first simulate the integrated circuits and the actual circuit before proceeding with the experiment to know the expected results. Check your wirings if they are shorted. Check your power source if it delivers enough power to operate and to be able to light up the LED being used. Lastly, try to determine the simplified versions of the circuit using Boolean algebra and observe what happens with the table and compare the results with the equations used. So that is it for our fourth experiment for our digital electronics laboratory.